Thank you, Iris, and welcome everyone to the first session of EMMSAD, which regards empirical studies. And we have two interesting papers. And the first one will be on exploratory study on student understanding of multi-perspective modeling, and it will be presented by Charlotte Verbruggen.
My presentation is about an exploratory study on students' understanding of multi-perspective modeling, written by myself and Professor Monique Snoeck. And the multi-perspective modeling that we focus on in this case is UML class diagrams in combination with BPMN process models. So BPMN and UML are used in education to teach students the methodology and principles behind developing information systems. And they are taught in different courses or different course sections, typically with exercises that are really tailored towards teaching a certain language or a certain aspect of a modeling language. In contrast, in practice, UML class diagrams and BPMN process models represent different perspectives of the same information system. So therefore, it's important that students are able to assign a certain requirement to the correct model. So when they see a case, they should be able to identify whether it's part of a UML class diagram or the BPMN process model. And they should also be able to ensure consistency between these models. In other words, they need to be able to co-model the data perspective and the process perspective. The Merode approach is a very good framework to teach this because it consists of a layered architecture. On the bottom, we have the enterprise layer where the domain model is included. So the domain model consists of a UML class diagram and also behavioral aspects modeled in finite state machines. Then on top of that, the information system service layer models the input and output services into the enterprise layer. And the third layer is the business process layer, where we can model the BPMN process. So when a student receives a case description, they should learn how to allocate a certain requirement to each of these layers. The Merode approach is taught in the course Architecture and Modeling of Management Information Systems. And here you can see 3 of the learning goals of this course. So first, the student should be capable of organizing requirements in the layered architecture. They should be able to performing a requirements analysis to create an enterprise model. And they should be able to relate this enterprise model to the BPMN process. However, there's a gap between what we just described as the requirements for students in practice and what's taught in this course. And that is creating the BPMN model itself. And that's why we developed our research question: does modeling the business process in combination with the domain model improve the student's understanding of which requirement is relevant for which layer? In order to research this, we used a thinking out loud experiment where students created the models, and then afterwards they filled in a survey to investigate their perceived understanding of these of multi-perspective modeling. The case we used was a hiring of PhD candidates. It's based on a different case from the paper cited at the bottom of the slides, but it was slightly adapted to make it manageable for students to create models. 6 students participated in the experiment. All of them currently follow the course that I just mentioned. The experiment took place when they had finished the 3rd chapter of the course, meaning that they had already been taught an overview of the Merode approach, but they were just starting to create the models. All of them have some experience with UML class diagrams and BPMN process models from previous courses that they took. And all of them received a demonstration on how to use Signavio, which is the tool that we used for our experiment. They were asked to first create a UML class diagram, then the business process model. Then afterwards, they were asked to explain the connections between these two models, and finally to fill in the survey. In each step of the process, they were allowed to go back and make changes to their previous models. This is the model solution of the case. So this is what we expected students to create. You can see that the UML class diagram is quite small, and the BPMN process is a bit more elaborate, but still manageable for these students that have already taken a course on BPMN beforehand. So now I'll go over our results. First, I corrected the models and I classified all of the mistakes that they made into 4 categories. You can see that the biggest category is the mistakes related to the BPMN model. The second category is mistakes related to notation, both for BPMN and for UML. And then we have mistakes related to the UML class diagram, and the smallest category is layer allocation mistakes. This means mistakes where a student would put a requirement into the UML model when it was supposed to be in the BPMN process model, or the other way around. The mistakes that occurred most frequently were the missing elements in the BPMN process model. And this can be explained by the fact that most students ran out of time. We provided an hour to finish this exercise, which we expected to be enough, but we learned that students actually needed more time to finish the exercise. Then, except for the missing elements, the error that occurred most frequently was modeling an actor of the business process as a class in the UML class diagram. Now we can take a look at our participants. The 2 participants that made the least amount of mistakes were participant 3 and 4, and they performed best overall. Then another interesting participant was participant 5. They didn't make many mistakes compared to the other participants, especially in the layer allocation category. However, their model was very small, very incomplete, which you can see also because 16 out of the 20 mistakes that they made are related to missing elements. So this, although it at first sight looks like a good model, can actually be seen as not a very good model. So now we can take a closer look at participants 3 and 4. They were the only participants that finished both models in time. They had the lowest number of mistakes overall. And when comparing the number of mistakes to the total amount of elements in their models, they also had the lowest ratio. These 3 elements show that their models were of a higher quality than the other participants. And then next, we also observed that they had a low number of layer allocation mistakes, more time explaining the connections between the models, so they were able to go more in depth into their explanation. And they were the only participants that, while explaining the connections, went back to their models to make changes to what they had modeled. So these 3 aspects indicate that they had the best understanding of the layered approach. So the first finding of our paper is that there could potentially be a correlation between model quality and understanding of the layers. Then we can take a look at the survey. 3 out of 6 students indicate that they had issues when allocating the requirements to the layers while they were creating the UML class diagram. And then 3 students indicated that creating the BPMN model helped them to identify the correct layers for the requirements. 3 out of 6 also indicated that the third part, so explaining the connections, was helpful to understand the interaction between the layers. And I think 2 of them went into detail saying that thinking out loud about these connections actually made them understand them better. All of the students said that after finishing part 2, creating the BPMN model, and part 3, explaining the relationships, they had a better understanding of the case. And then 4 out of 6 said they understood the layers in general better after performing these 2 tasks. 3 out of 6 say that including this type of exercise would be helpful for them to study the course. And 5 out of 6 say that code generation or simulating the business process would also be helpful to gain understanding of these layers. So in conclusion, we identified a potential correlation between model quality and the understanding of multi-perspective modeling. Modeling the actors seems to be a challenge for novice modelers, but further research is needed to generalize these findings because our study only included 6 students. I will finish my presentation with some considerations for future experiments. When we repeat this experiment, we of course want to include more participants to make sure that the findings can be generalized. We want to allow the students to choose the order in which they create the models and see if better students have certain behavior patterns when they are creating these models. We also want to consider the correctly modeled aspects of the solutions. In this study, we only focused on the mistakes that the students made, but it would be interesting to see if the scores are different when we consider the correctly modeled aspects. We need to allow more time per student to make sure that the time constraint is not a factor in their solutions. And we want to provide tool training beforehand. Several students seem to struggle with using the tool while we had sent them a demonstration. So it would be helpful to give tool training beforehand to make sure that that's not an issue. Finally, there were some limitations of the thinking out loud exercise. Many students were hesitant to express their thoughts while they were still unsure of their solution. Also, many students were not native English speakers, so they had struggles explaining their thoughts. So this is a consideration for future experiments as well. With that, I conclude my presentation, and now we have time for questions.
Maybe they hear without. Is it not? Is it better? Thank you for the presentation, and definitely interesting topic. How one should combine different models in order to recognize or some knowledge that it is not obtained, like in this case for those layers. by the students. My question is very straightforward. When you had the results of these 6 students and half of them were saying or learning one thing and half not, what would be your suggestion when you have 50%, 50%? What you then, as a scientist, learn? How do you proceed? Do you need additional group of students? What do you think? Or is there something other that such experiments are guiding us to do?
Okay. Well, first I would definitely say that we need more students because with 6 students we cannot really say that this is generalizable. I think from talking to the students, some of them that indicated that they learned from this exercise also had better solutions of themselves. So maybe the exercise was more helpful for students that already had better skills. But I cannot create a conclusion because there were only 3 students, so there are just not enough participants to generalize. Yes, I would redo the experiment, improve the setup a bit, and try to include a lot more students.
Fetch the mic, thank you. Okay, I think also that your experiment is pretty important for our teaching, for all our teaching perhaps. And with respect to your method, I'm wondering, you assume that students can sub-vocalize everything. How did you deal with it when students did not find the right terms? Did you then say, okay, this term is similar, and so you counted it in your table?
Well, maybe
okay, I can bring you the mic.
No, I can speak like this.
Okay.
So the question was when students were not sure of the term to use in the model?
Exactly. So if they did not find the appropriate term, so because you assume that sub-vocalization is possible, that you can think and directly articulate during modeling, but that's not at least as I behave, to be honest. So if students did not find the right word, how did you deal with it?
I tried not to intervene with the students, so they had a text with all with the case description, and they were thinking out loud to themselves, and I didn't intervene just to make sure that I didn't influence the results. So yeah.
Okay, so no mapping in between, to say. Okay, great. There was another question, I guess.
Okay, thank you. My name is Bert de Brok. I have a few questions, and some were more or less asked or answered by you. But the first one, you said in the beginning something like requirement, they have to classify the requirements into one of the categories or layers or whatever. However, a requirement could belong to more than one category, wouldn't it?
Yes, that's also a possibility. So students had to decide for themselves whether to put it only in the UML model, only in the BPMN model, or in both.
Okay, yes. And I missed more or less why you... So 6 students, and they were groups of 2, I think?
2 students had the best solution.
No, but there were 6 solutions, or were there 3 solutions of groups of 2 students?
No, each student had an individual solution.
Okay, so 6.
Yeah.
But I missed why only 6, because we have a similar course with about 150 students. Why only 6?
It was a voluntary experiment, so we asked for students to participate voluntarily. And it was still at the beginning of the course, so I think a lot of students were maybe a bit insecure about their knowledge.
Okay, so it is more or less besides the course itself, Because in order to increase the numbers, you could also say, well, it will be part of the course. So everybody of my 150 students, and maybe you have 100 or so, they all have to do it.
Yes, that's an idea for the next iteration of the experiment.
Because these numbers are so low that you hardly can draw conclusions. Because well, no, but you could say, well, part of this course in order, so in our course they have to do things. For instance, this could be one of the things they have to do, and they get a note for it. And okay, then you can ask them, is it allowed for me to do blah, 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 and then out of the 100 you get only 60 or so, whatever. Okay, that might be. But anyway, it should be part of the course. They have to do it, and then you can do your research. I also had this fixed time, doubts about this fixed time, but you already said we will change that.
Yes.
And yeah, about how many people said, well, it helped. So there were 3 out of 6 and 4 out of 6. Doesn't a method always help?
Yes, so this is the perception of the students.
Yeah, but I would say, if 3 out of 6 or 4 out of 6, the numbers are too small, that is only 50% or 65%. Despite, I would almost say, despite the method. So if the method is good, I would have expected very high numbers. And because a method will always help, I suppose. But again, the numbers are too small to make this kind of conclusions. And then finally, what I did in the course I was talking about, I made a list of common mistakes. So the mistakes I saw in those works, in my students, I made a list of common mistakes. I also put it in the book, which I'm writing now. And because these are typically mistakes, you and I, we wouldn't make them, but our junior students will typically make these kind of mistakes. And I recognize some of them.
Good morning. Thank you for the presentation. I have a doubt about the modeling tool the students use to design the models. And in particular, if you think that the tool itself may have affected to the quality of the designs. I mean, for instance, if the tool, difficult to use, may have introduced some of the mistakes or not?
It's a possibility, although we try to take this into account by giving them the demonstration beforehand. They had also used this tool in a course that they took for most students the semester before. And additionally, the only time I intervened was if they had a question about the tool, they were allowed to ask me for help. So I wouldn't change anything about their solution, but if they didn't know where to find a certain element, I would show them how to model it. So I hope that by doing taking these 3 things into account, the difficulties related to the tool didn't affect the results.
Thank you very much.
Thank you for the nice presentation and for also doing research. I know what you're doing. I think this is very, very important to understand better how models are created and what are the thinking processes behind that. I have one question and also one aspect regarding the tooling. So maybe I start with the tooling part. I also have this issue. You mentioned you're using Signavio, right? And if I recall it correctly, in Signavio, there's a lot of validity checks already going on. Did you make sure to kind of cut out this functionality? Because otherwise the students already get a hint that for example, any gateway doesn't have a label specified or message flows that are running crossing pools. So there's a lot of validity checks that would actually, so it's kind of testing whether the students can work with a tool and create models instead of testing their understanding. Did you think about this?
They were turned off,
Okay.
I think. And a lot of students made these types of mistakes where they didn't put labels on gateways and used wrong arrows to show message flows. So, yeah.
Okay, great. That's good to know that you can turn it off. And the other question related to the setup of the experiment. When I saw your first slide, I would have expected that you were interested to see whether this multi-perspective approach fosters understanding, right? So naturally or intuitively, I would have said this calls for a within-subject study where you have one group of students doing a multi, maybe, and another group only doing UML or only BPMN, and then have the same questionnaire and survey and see if you can find some, is this planned for the future, or why did you go with this path? Not as a critic, but as a...
Since there were only 6 students participated, the group was too small. I tried to, by asking them to start with the UML model and then move on to the BPMN model. In the questionnaire, the first question is how did you have issues with allocating requirements to the correct layer while only working on the UML model? And then the questionnaire continues to the second and the third part of the exercise. So that's how I try to have some insight into that. But if we have a larger group, then a setup like that with different groups would be a good idea, I think. Yeah.
Yeah, I also think so. It would be very interesting. I have many more, but I don't want to. I have at least one more, because you also mentioned in your response that the students created first the class diagram. And I already in your slides, I thought for me that's counterintuitive. Because when we talk about enterprise architecture or layered approaches, we always go from strategy, business layer, then down to technology, right? So was this a cautious decision, or was this based on Merode? Excuse if I'm not an expert, that this is the procedure of how a Merode should be applied?
It's based on the Merode approach. So in the lectures that they had already followed, they had been taught that requirements analysis happens from top down, so from business process down to the enterprise layer. But when you're modeling, you start with the enterprise layer according to Merode, because it's the basis, and then the information services and the business process builds on top of that. So that's why I asked them to do it in that order, but some of the students indicated that they would prefer to do it the other way around. So that's why I would eliminate this aspect in the next iteration to give them the freedom to choose.
Okay, thank you. There's some work from Selmin and Afef Avadit. They also did some experimental studies on 3 different languages and whether it has an influence in which sequence they are modeled. So maybe I can send you a reference if you want.
Okay, maybe short questions from my side. So when the participant try to model, they have some purpose in mind? So were they able to design information system, to generate code, or just understanding the requirement? What was the purpose that was delivered to the participants?
They were not able to generate code, so they were just asked to create the models. It would be also interesting to do the experiment later in the course, because in the course that we give, the students use a code generator, and it generates code for the enterprise layer. So they have a prototype of an application based on the UML model that they created. So we don't have it for the business process layer, but that would help them to see if what they modeled represents the case description.
I see. So actually they were asked to model the requirements, not just to design or towards implementation. Okay. The other thing I want to ask is about the training. It seems that the mistakes that were banned by these participants are pretty fundamental. So missing classes or things like that. So maybe it is better to have the experiment later in the course, so we have more training, more background, so they can avoid such mistakes.
Yes, that's true. The students that participated, like I said, they all had taken courses on these topics before. And we were also a little bit surprised by how many fundamental mistakes they made. So when we checked their performance in these courses, they actually had quite high performance. So that's definitely a surprising result. So indeed, if we put the experiment at the end of the course, then maybe that's an effect that doesn't happen anymore.
I see. Okay. Any other questions?
Yeah, I wonder about the effect of novices doing things versus people who have more experience. So, for instance, what would happen if you did exactly the same experiment, except after they had done 3 of these? So they'd done 3 different examples, and now you give them the 4th and see what the results are. Do you think you would get the same kind of result, or do you think it would turn out to be different because now they had a better idea of what they were doing?
I would expect that if they are given 4 different cases, that the 4th case is better because they learn how these models interact by making mistakes in the first models that they create. So yeah.
Yes, I think even much better, because in the beginning there are a lot of mistakes, as you said, and it's also my experience that I see, and then many of them learn very quickly. So the 4th experiment will be much better.
So maybe another issue is regarding the motivation of the participants to engage into the task. So it refers also to the points raised before. So how can you motivate them to have the highest possible quality model?
Yeah, that's a very good question. Yes, the issue is that students that choose to participate should not have an advantage over students that don't participate in the grading of the course. So that's a bit of a balancing act to ensure that from an ethical perspective, all students have the same opportunities, and also that we ensure high motivation for our experiment.
I totally agree, but in that sense, you cannot ensure or engage them in that sense. So my experience with doing a lot of experiments with students, if you're not giving them some motivation in terms of compensation by the grade, compensation, monetary compensation, the motivation is quite limited. But maybe in Belgium it's differently. Any other questions? Okay, thank you, Charlotte.